resistors in series and parallel. So what are series resistors? Well, let's just start out with drawing kind of a basic sketch of some resistors in series. I'm just going to put some numbers on them. Let's say the first one is 1 ohm, say 5 ohm. Then we'll say the third one is 8 ohms. So we'll say resistors in series, well, that's just going to be whatever R1 is plus R2 all the way to Rn, just how many you have. So let's do that for the three we have. So we can say the R equivalent, or the equivalent resistance, is going to be 1 ohm plus 5 ohms plus 8 ohms, which of course 1 plus 5 is going to be 6, and then 6 plus 8, 14 ohms. So we can simplify this by just writing 14 ohms. Now let's try something that's a little bit more involved sometimes, but once you do one or two examples, it's going to be super easy. Let's do parallel resistance. First, we're going to symbolize it as these two lines. That just shows that some resistors are in parallel. You can have another one on there for R3, however many you want. Now let's take these same resistors, 1, 5, and 8 ohms, and let's draw those in parallel. So we have our start. We're going to come to a node, and we're going to split into 3 branches. 1 ohm, 5 ohm, and 8 ohms. Then our node comes back together, and we continue on. So with these 3 parallel resistors, what's our resistance going to be? That's going to be a little bit more involved, but not by much. So anytime you have resistors in parallel, no matter how many, this is the basic equation. You can say 1 over your equivalent resistance, or Req, is going to equal 1 over R1 plus 1 over R2 plus however many you got, all the way up to your nth resistor. But then you got to come back and get rid of this 1 over Req. So we could just write it as Req, or equivalent resistance, is equal to 1 over R1 plus 1 over R2 plus however many resistors you have to the power of -1. So let's do that with our 1, 5, and 8 ohm resistors. So that's going to be 1 over 1 ohm plus 1 over 5 ohms plus 1 over 8 ohms raised to the -1. So let's do a little bit of algebra here. Or not even algebra, it's less than algebra. Let's just do some basic simplification. So 1, 5, and 8 on the bottom of these fractions. So we know that we're going to have a denominator of 40 to make everything equivalent. So this we'll write over 40. And we'll have 40 plus 8 plus 5 to the -1, which is just 53 over 40 to the -1, which of course is just 40 over 53. Now if you like decimals, no problem. That's about 0.75 ohms of resistance from these resistors that are in parallel. So something really important that I want to note about parallel resistors. Your equivalent resistance will always be less than your smallest resistor. So we know that we have a 1 ohm resistor here. That means we have to end up with something less than 1 ohm. If you don't, whatever your smallest resistor is, if you don't end up smaller than that, you got it wrong. Another really important concept I want to point out with these parallel resistors, just to make things quick and easy, if you have two resistors that are parallel and they're equal to each other, divide them by 2, and you have an equivalence of that value. So here we have 20 and 20. 20 divided by 2 is 10. We could have We could have 500 and 500 ohms, and of course then our equivalents will be, any guess? 250. So now let's do something a little bit more complicated with combination resistors. This is where we have series and parallel together. So let's take something like, start there. Let's have, I don't know, I'm just going to say 200 ohms, 100 ohms, and then let's do 900 ohms, 900 ohms, and 900 ohms. And parallel. So we can simplify this one step at a time. So first, let's simplify these. So these are in series, so we just got to do 200 plus 100. That's going to be 300 ohms. Now we have this 900, 900, and 900 all in parallel. So just like when we had two resistors of the same resistance in parallel, we can divide by 2, and that's the value. Because we have 3, and they're all equal, we can take their value, which is 900, divide by 3, and that's going to be the equivalent. So 900 divided by 3 equals 300 ohms. And let's do that a little bit more drawn out just to kind of see what's happening. So if we're going to do our R parallel, we'll do it down here. I'm just going to do RP for R parallel. That's going to be 1 over 900 ohms plus 1 over 900 ohms plus 1 over 900 ohms, all to the negative 1, which of course is going to equal 3 over 900 ohms to the negative 1, which is 900 ohms divided by 3, which of course is 300 ohms. So now we can fill that in here. So I'm just going to draw an arrow to that. This becomes that. And of course, our final answer, 300 plus 300 that are in series is 600 ohms. And that is your final answer. So that's how you do something that's in combination. I hope that helped. Like, subscribe if you got anything out of this. Thank you so much for your time.